This term is called symmetry term. Because it makes the nucleus symmetric in protons and neutrons. Okay, so this term is negative, you can see. Okay, so minus A symmetry multiplied by this factor so it reduces, since it's negative, it is reducing in importance for large A. You know, as the atomic mass increases, the value of this term decreases. So now you can when you look at that graph again, it was also emphasized in the video and I explained it while we were playing it. In the beginning of this graph, you have the light nuclei like hydrogen, tritium, deuterium, right? And then you go to the top, this is around iron, then the graph starts going down towards the heavy nuclei like uranium, right? And you see that the behavior is different. What's different? What's the main difference in these is the number of nucleons. So you see this number plays a very important role. Okay. So you can take a photo. Okay. And now I'm going to erase this part. Okay. So यहाँ पे the last term so the last term accounts for the tendency of like nucleons to couple pairwise, to make pairs, right? This leads to stability. Okay. So this shows you the presence of a term which represents the tendency of these nucleons to exist in pairs, and this therefore produces stability in the whole system. Okay.
The nucleons have a tendency to stay in here, right?
Yeah. We are going to explain this further. Let's explain it, okay? Because we are going to talk about the significance of odd number of nucleons and the significance of even number of nucleons. I think that's what your question is related to.
My question was, what pair would be more stable, a neutron-proton pair or a proton-proton pair or a neutron-neutron pair?
Wow. Okay, so let's look at the different. There are different properties of these pairs that will be that we have to take into account in order to understand how this works. So let's start with this. When odd number of nucleons Odd number of nucleons would mean odd A, right? And this would mean Z plus N is equal to odd. Okay? This term does not contribute. Okay? And when both Z and N are odd, the binding energy is gained by converting one of the odd protons into a neutron or vice versa.
So that's the beta decay.
Yes, that's interesting, right? Every discovery has a history behind it. Every time scientists were stuck at a problem, and this led to a new discovery. Whenever you're stuck, actually it's a blessing for you, because then you will dig deeper and you will find the real answer there, right? So what is this? Are you familiar with these symbols? Huh?
The ghost particles, neutrinos.
Neutrinos. Why are they called ghost particles?
Because they're very hard to detect.
Yeah, yeah. And also it was very difficult for people in the beginning to understand that they exist.
And people
Yeah.
think that they are less charged particles.
Yeah. They're difficult to detect, they were difficult to understand, and in the beginning people did not realize that they existed in the beta reaction. It was later on that it was confirmed that they do exist. Okay, now, so we also talked about this last time, that a neutron can convert into a proton and vice versa in order to stabilize the system, right? And so it can now form a pair with its formally odd partner. So the purpose was to make a pair. So there's a natural process to gain stability, right? And radioactivity is an example of this. When a nucleus becomes very unstable, so it emits radiation in order to stabilize itself, right? So that it can now form a pair, as we said before, with its formally odd partner. So, and delta, as we just said, represents pairing force. Okay, you can take a photo. हो गया? Okay.